Pore space, the openings between the geologic material, between the grains of sand or the pieces of gravel underground. And it is these openings, or they're called void spaces, or this funny word here down at the bottom, interstices. I will try to refrain from calling it that because that's a foreign word to most of us. We don't recognize that. But pore spaces, we should be able to recognize it. Okay, we're talking about the space between each grain of sand or gravel or something like that. This is a place that can hold air or water. Recharge, water added to the aquifer. Okay, our example, very simple. It rains and it seeps or infiltrates into the ground and recharges the aquifer. This is an input to the aquifer. The recharge zone or area, an area where permeable soil or rock allows water to seep into the ground to replenish an aquifer. As we look at this diagram, all of this is the recharge zone. Okay? There is no, if rain falls on this land, it's recharging this aquifer. There is no place where there is impermeable rock on top of this aquifer. Remediation. This is another word that people struggle with. They're not real familiar with it. It says containment, treatment, or removal of contaminated groundwater. Remediate, to fix. Okay, so if we have a groundwater pollution problem, we need to remediate it. So we'll be talking about remediation techniques. And when we say this, we're talking about, man, how are we going to contain this pollutant and treat it or get it out so that we can use our aquifer again and that we're not contaminating people's wells. Residence time, period of time that groundwater stays in the aquifer. How long does it take to move through that aquifer? We can talk about residence time in a surface water body too. Which one is going to be longer? Well, hopefully you realize it's going to be in the groundwater because it takes time to move through these sediments, the sand or the gravel or something like that. It is not exposed to things like evaporation. Okay, so it's going to spend more time in the ground generally. Saltwater intrusion, we're not going to talk about this a whole lot. This just happens to be a diagram of an island aquifer, and you can see here in the purple, salty groundwater, because it's under the ocean here. And the example would be this well on the edge. If they overpump, they could suck that water into their well. That would be called saltwater intrusion. And now they're in trouble because that is not potable. You cannot drink salt water. Well, you could, but it's not going to be good for you. The saturation zone is the groundwater zone. This is below a surface that's saturated with water, called the zone of saturation. It is below the water table. Okay. So we have the water table, below it's the groundwater zone or the saturation zone, the zone of saturation, whatever you want to call it. It is the area where all the little pore spaces are filled with water. It is below the water table. Strata are different layers of different kinds of soils or rocks. You've heard me say this word before already. For different stratas, we're talking about clay, gravel, sand, the different layers. In your model aquifers, you'll probably have 3 different strata. You'll probably have maybe some clay or something representing clay, some gravel, and maybe a little bit of sand. Subsidence. It's a depression of the land surface as a result of groundwater being pumped. If we overpump, we're taking that water out quicker than it's coming in, and we will leave void spaces, meaning the pore spaces are no longer filled with water. It says cracks or fissures can appear in the land. Subsidence is basically irreversible. What we're basically doing is mining the water out of an aquifer, and then the land will collapse upon itself because we've taken the water out, which was taking up space and therefore supporting the land. To give you an idea of how large this hole is, look at these trucks here in the background. Imagine pulling that truck up. It might be not too much bigger than my cursor sitting here on the top of the hole here. Surface water. Water above the surface of the land. We're talking lakes, rivers, streams, ponds, floodwater, runoff. Pretty straightforward. Sustainable yield or safe yield. This is the amount that you can take out without depleting your aquifer. So in this case, okay, the left-hand diagram would be practicing sustainable yield. You can sustain the aquifer, it's remaining the same. And on the right-hand side here, that's overpumping. This is not sustainable yield. Okay, we are drawing down the aquifer, we are mining it. The water table, the top of an unconfined aquifer indicates the level below which soil and rock are saturated with water. So basically, think that you need to think of the water table as it's just the top of the groundwater zone or the zone of saturation. It's the water level underground. So when we're looking at our aquifers, we'll look at them from the side. Remember that profile, that side view, and it is wherever the water level is on the side of our model aquifer. Okay, that's the water table, and it separates the groundwater zone and the unsaturated zone, or I should say saturated zone underneath the water table and unsaturated zone above the water table. Well siting is just the idea of where the heck are we going to put our well so that it's the safest well that it can be. In other words, the chances that it will get contaminated are really slim. This diagram shows one place maybe not to put the well. If the groundwater flow is actually going left to right in this photo, maybe we want to switch these around, and the well should be over here and the drain field should be on the right hand side. Okay, if that's direction of water movement, that would make much more sense. So well siting is putting the wells in the safest place possible. Wellhead protection area. This is a protected surface and subsurface or underground zone surrounding the well, supplying a public water system to keep contaminants from reaching the well water. In other words, a well protection area is an area where we really want to watch out what happens on the surface and directly below the surface where our wells are, so that they do not become contaminated. Okay, so wherever our well might be collecting water from as it seeps through the ground, we want to make sure that's a safe area. Withdrawal, the amount of water removed from a surface or groundwater source for use. Okay, go through these again as you need to. Check out these diagrams again to refresh your memory as you're looking at your notes. But we certainly need to be talking about these things as we go over aquifer. So next, head into that aquifer project with you and a partner, and good luck.